Okay, let's continue with combination. So combinations is the second part of the chapters. So the first part we have seen, we have discussed on permutation. So combination is just the extension from permutation, where still we use the concept or the principle of counting. Okay, but here we will see. Okay, sometime, okay, in a situation, okay, we need to arrange something or we have to select something, but when you select, the arrangement will be not important. So when this the situation is when the situation is when the arrangement not important. Okay, when you select something. Okay, so we will use the formula for combination, or we will call the situation a combination. Okay, so we can see this is the definition of it. Okay, combination means it's a technique, okay, that determines the number of possible arrangement in a selection. So we arrange, but or we can say we select. So when we select something, okay, the order doesn't matter. So please remember, combination is when we select something where the orders does not matter. So from the logic of it, okay, we will know that combination, if we have same situation like permutation, okay, and when the arrangement is not important, it's not a matter, so that means we have less or fewer combination, okay, or the answer will be smaller in value. Okay, then the combination will be subset of the permutation in the same situation. Okay, so let us see. So what happened when the order doesn't matter? So that means if we see the example that I used, okay, last for permutation, yeah, okay, 1 2 3 and 3 2 3 1 and 3 2 1, it will be counted as 1 because the order doesn't matter. It means that it doesn't matter where the 2 or the 3 or the 1 is arranged, okay, as long as they are being selected. Okay, so they are the same. So remember this example that we have last time, okay, when we choose or we arrange, okay, two letter from the letter A, B, C, D, E. Now let's say it's under same situation, okay, but now the order doesn't matter. So what I can say here, after we list down, okay, the time when we do this, okay, we will have 20 possible arrangement. When you have 5, you choose 2, okay, you choose 2 to arrange in 2 spaces. Okay, you have 2 spaces to fill in the letter, so you have 20 type of arrangement. But when come to combination, okay, the 20 combination and the 20 arrangement that you have previously, now there are some of it, okay, some of it are count as one. Like me, for example, you see AB and BA, they are same, okay, because order doesn't matter. Okay, AC and CA are the same, okay, because order doesn't matter. So same and go on. So okay, so we can use the logic here. So out of 20, okay, actually half of them are the repeated one. So we can modify, okay, the formula for permutation into combination, okay, by, okay, you see this one is a way I select, okay, so since order doesn't matter, so it's a repeated, so the possibility is half, okay, it become half of it. Okay, so how to change the formula? Okay, that may not change, actually we just modify a bit. So now we don't use the word P, yeah, since we are using selection, okay, selection, we use the word C, okay, the combination of numbers or the combination of code or combination of way to select something. Okay, so you can see n factorial, okay, divide by n minus r factorial. This one, part of it is still permutation, but since we have fewer possibility now, okay, so you divide with the r factorial. So back to the same formula that you used for the A, B, C, D, E, yeah, choose 2, okay, now if we want to only choose 2 without taking care of the arrangement, I mean doesn't matter the way it arranged, okay, we just want to have 2 letter out of the 5 letter, we might get 10 types of letter, okay, 10 type of set of letters that can be choose. Okay, so that is how we do. Okay, the factorial still same, huh? Okay, factorial, if 5 factorial means 5 4 3 2 1. Okay, 2 factorial means 2 times 1. Okay, 3 factorial means 3 times 2 times 1. So the factorial concept is still there. Okay, same. Okay, so let us see one example here. So the student must answer 3 question out of 5 question, essay question in a test. So the student may, the way of your thinking, they may choose question 1 2 3, or they will choose question 2 3 4, or it will choose the question 3 4 5. Okay, so or they will choose question 3 first, then question 2, then question 1. But 3 2 1 or 1 2 3 is still the same question, right? Same, because the order doesn't matter as long as they answer 3 questions. So those who answer 1 2 3 and those who answer 3, they answer 2, they answer 1, same also. Okay, just that they choose to answer number 3 first, but still they are answering the same question. Okay, so when we come to think about it, this question we will use combination instead of permutation. Okay, so we will see how. Okay, so we just use the formula lah, 5C3. Okay, please, this one is not like this. 5, there are 2 way of writing. Either you can write the 5 on top of C, and then C, on the left hand side of top left of the C, and then the 3 at down. Okay, right hand side down right hand side of the C. Or you can use the previous way. Okay, or you just use on the left. Okay, 5 3 on top and down. Okay, is the way of writing, but this one is not acceptable. Okay, some typo here. Okay, so the 5 should be going up. Okay, 5C3. Okay, so then the formula is correct. Okay, then a basketball team. Okay, this one is a bit complicated. Okay, because you see, so when we do, we have to think a bit. Okay, we have to use some logic here. Okay, so the basketball team consists of 2 center. You know, this one is basketball, so they want to play with 2 people at the center, 5 go to the forward, and 4 guards. Okay, so how many ways can the coach select a selecting line for each one center, for 2 forward and 2 guards? Okay, so that means we have how many people here? Okay, so for the center you have 2 people. Okay, I only select 1. Okay, then 5 forward. I have 5 people in the forward, but I need only 2. You see? Okay, because in one game we have only 5 people. Do you know basketball? Okay, basketball you have one team 5 people. So 1 at the center, 2 forward, and 2 will be the guards. Okay, but in the team they have 2 center, 2 people who train as a center, 5 people who are trained as a forward, and 4 people are then trained as guards. So now the coach want to select people to join into the tournament. Okay, or the competition. Okay, so now out of the 2 center that he had trained, okay, he had to choose only 1 people to join the tournament. You can see here 2C1. Okay, this is the correct way of to write. Okay, on the left side, 1 on top, 1 at the bottom, 2C1. So 2 factorial divided by 1, 2 minus 1 is 1. So 1 factorial is 1. Okay, so it's 2 lah. Okay, to choose the center, this is the possible way. Okay, to choose the forward. Okay, so you have 5 trained. Okay, so you only need 2 in the competition. So 5C2. So this is the way. Okay, then third one, how to choose the guard. Okay, the guard you have 4, you only need 2. Okay, so 4C2. So same thing, so you're 6. So finally you have to multiply all together. This is the counting fundamental, the counting principle. Yeah. Okay, so when we multiply together, it is 122 possibility. So if you are one of the player, okay, you are one of the player, the possibility to be chosen, if you are the center, is 5 per 1 over 2 lah. Okay, if you is a forward, is 1 over 10. Okay, if you are a guard, then you are 1 over 6. Let's say you are trained for all the thing, then the possibility of getting is 1 over 120. Okay, that is how we think. Okay, so last question you do yourself lah. Okay, it's not difficult. The answer is given here. You just think a bit, then you get your answer. And then in your textbook, please proceed with the practice, the exercise 6.2. Okay, do all, it's quite a lot, I know. Okay, so you need some time to do. Okay, so that's why I give you the explanation earlier, so I hope you can do in the week. Okay, you need a lot of practice and thinking, okay, in order to score. Alright, so I have a bit of conclusion here. So see, okay, this is the difference between permutation and combination. Okay, you can just read it up. Okay, I will share this slide for you lah. Okay, so permutation and combination, so both are the way to count possibility, as you see. So the possibility of selecting or possibility of arranging. Okay, then the difference is whether the order matters or not. Okay, so when the order is not matter, we are calling it combination, or we use combination. If the order is matter, so we use permutation. So this one is consider the number thrown in 3 dice is the same as this one is combination. Okay, the example 2 given here. If yes, you see, if it's matter, then it's a permutation. If it's not, then it's a combination. So this is very easy lah. It's very easy chapters. Okay, as long as you understand the principle of counting and you know that permutation and combination, actually we are finding the possibility of outcome. Okay, the possibility of outcome, then we will use this in the next topic. Okay, where we come with probability. Okay, probability, then we will need some of the information or the logic thinking here. Okay, so this one is to train you to think. Okay, you have to think to get your answer. Okay, sometimes we do not need the formula also. Okay, we can just get answer without knowing the formula. Okay, just use the counting principle. Okay, it's no wrong. Okay, anything that is good for you, I mean you can understand, then you just go ahead. Okay, so I will stop here. Okay, thank you. Please remember to do all the exercise 6.2 in your textbook. Okay. Okay, before we end, this is the videos on permutation and combination. I hope you can understand. Thank you.
We have seen more than 10 problems based on permutations and combinations, and we have used logic to solve all of those. Once we understand the logic, there is no harm in using the formulae which we will see in this session. We know that permutation is about arranging things and combination is about selecting things. But we need to get a deeper understanding of this. Is it extremely easy to figure out the difference between arrangement and selection? Before we get to a few examples, let's understand the notation. If we have to arrange R things out of N, it's written as NPR. Arranging R things out of N. We use P as its permutations. And for selecting R things out of N, we write it as NCR. C for combinations. Let's zoom out and discuss each of these in detail. Permutations is about arrangement. But what does this arrangement tell us? What is it that explains this word? It tells us that the order matters. The order at which the things are placed matters. ABC and ACB will be different. 1, 2, 3 will be different from 2, 3, 1 and so on. And what about combination? Combination is selection. Selection is simply picking a few things. Here, the order does not matter. Say from the digits 1, 2, 3, 4, 5, we picked up 1, 3 and 4. Picking up 1, 3, 4 is the same as picking up 4, 1, 3. They are not two different cases. Let me give you a permutation example. Assume we have to pick a team of 3 people out of the available 10. One of them will be chosen as a vice president, another as a manager, and another as a product developer. This is a classic case of permutation. The order matters. If we select A, B, and C, then it can be a case of VP, manager, product developer. Or maybe A is chosen as a product developer, B as vice president, and C as a manager. Each case is different. On the other hand, if we are asked to select a leadership team of 3 out of 10 and told nothing else about it, then it is a case of combination. The order does not matter. Selecting A, B and C is the same as selecting B, C and A or C, A and B. Take another example. Say 2 out of 5 people get ice cream. One gets vanilla and the other gets chocolate. This is a case of permutation, as each of the 2 people selected may get either vanilla or chocolate flavored ice cream. And if we are just told that 2 out of 5 get ice cream, it will be a case of combination. We aren't told anything else, just that 2 out of 5 get ice cream. So the order clearly does not matter. Now that we have understood what permutations and combinations are, we can move on to the formulae. First, we look at NPR, arranging R things out of N distinct objects, and repetition is not allowed. For example, let's assume we have digits 1, 2, 3 and 4. And we have been asked the number of ways in which we can form 3-digit numbers using these 4 digits. For this formula, we cannot consider cases such as 111 or 232 or 441. The digits are repeated in each case. So the objects have to be distinct and there can be no repetition. So this equals n factorial divided by n minus r factorial. Yes, that's the formula. If we have to arrange 3 people out of 10, it will equal 10 factorial divided by 10 minus 3 factorial. Don't worry, we will look at numerical examples later. For now, let's just look at the formulae. We move on to combinations now. NCR. It's selecting 3 things from 10 distinct things. This will equal n factorial divided by r factorial times n minus r factorial. Yes, that's the formula for combinations. If we have to select 2 out of 5, the number of ways in which it can be done is 5 factorial divided by 2 factorial times 5 minus 2 factorial. At first, these formulae look scary, but as you start practicing, you will see that using these formulae gets us the answer really quick.